Bismillahir Rahmanir Rahim. All right, so this is lecture number 1.4, part 1 of lecture number 1.4 for International A-Level Edexcel P3. Okay, in the previous lecture, we talked about improper fractions. Okay, we covered the basic concept of improper fractions. We did a few examples and a few questions of exercise 1C. I guess there was only one question of exercise 1C, which we did in the previous lecture. Okay, and now here we have another question, exercise 1C, question number 10. Okay, and after this question, we are going to start the topical past paper handout of this chapter number 1 of International A-Level at Excel P3. So immediately after this question, we are going to start the past paper handout. So first of all, we have this question. This is an exam style question, question number 10 of exercise 1C. We need to fully factorize the expression x raised to the power of 4 minus 1. All right, so very simple, very easy. First thing first, as we know that in place of x raised to the power of 4 minus 1, in place of this expression, we can write x square whole squared and then subtract 1 square. So this becomes a difference of squares, as we are already aware of the fact that when a square minus b square is factorized, so what you get is a plus b multiplied by a minus b. This you are studying since O level and IGCSE mathematics. Okay, even P1 as well. So in place of x square whole squared minus 1 squared, we can write x square minus 1 multiplied by x square plus 1. And further, we can factorize x square minus 1 as well, because we have again identified that this is the difference of the squares. However, this x square plus 1 will remain as it is because it cannot be factorized into any form. This x square plus 1 will remain as it is because we cannot factorize a square plus b square. Okay, so we are only going to factorize x square minus 1, which is going to be x plus 1 into x minus 1, and then this will be multiplied by x square plus 1. So here you have achieved the fully factorized form of part A. Okay, and now in part B, it says that hence or otherwise write the algebraic fraction x raised to the power of 4 minus 1 upon x plus 1 in the form of ax plus b multiplied by cx square plus dx plus e, and find the values of a, b, c, d, and e. Okay, so first thing, just focus on this word hence. Hence means we are using the outcome of part A. We are using the answer of part A in our further calculations, in our further working. Okay, and then I'm going to talk about this otherwise, the alternative approach, on the very next page. On this page specifically, I'm going to talk about this hence. Hence means that we are using the outcome of part A in the solution of part B. All right, so x raised to the power of 4 minus 1 divided by x plus 1. And as we have seen that, in place of this numerator, I can write x plus 1 into x minus 1 into x square plus 1. Okay, and this is completely divided by x plus 1. So we can see that x plus 1 and x plus 1 got cancelled out, eliminated. So therefore, x minus 1 multiplied by x square plus 1. But we need our answer in this specific form. So yes, we have obtained this specific form, ax plus b multiplied by cx square plus dx plus e. So we are just going to make a comparison that the coefficient of x is a, so a is equals to 1, and b will be equals to minus 1, c will be equals to 1 because c is the coefficient of x square, and term in x is not existing over here, so therefore d will be equal to 0, meaning the coefficient of x will be 0 and e is equals to 1. Okay, so a is 1, b is minus 1, c is 1, d is 0, and e is 1. In this way, we have attempted this part B in such a way that we have used the answer of part A in our further solution. Now I'm going to talk about this otherwise on the very next page. Okay, so I hope you have copied this much working. Okay, so here we have an alternative approach for part B, which is by using the long division method. Okay, otherwise. So in this case, what I'm going to do is I'm going to divide this polynomial with a degree of 4. I'm going to divide this polynomial by linear expression x plus 1. Okay, this is a way of saying that polynomial is divided by another polynomial, meaning the polynomial is divided by a divisor, obviously. Okay, so x raised to the power of 4 minus 1, this is going to be divided by x plus 1. So what you know is that, we have done so many questions now. Okay, I've repeatedly mentioned this thing. I'm again mentioning this thing, that in long division method, we write the polynomial in a strict sequence. So x raised to the power of 4, then conceptually there should be a term in x cube, which is not existing over here. X cube की term होनी चाहिए, जो कि नहीं है, गायब है. So the coefficient of x cube is 0. And in the same way, the coefficient of x square is also 0. In the same way, the coefficient of x is also 0. And then we have minus 1. Okay, so we are going to write the polynomial in a strict sequence whenever we are using the long division method. Okay, so I hope this thing is clear. Okay, we have done so many questions up till now, and we are using this practice since P2 as well. Okay, so you need to ask yourself by what term you multiply x such that you get x raised to the power of 4. Obviously, you need to multiply x by x cube. So x raised to the power of 4 comes as it is underneath x raised to the power of 4. And then this x cube is multiplied by 1, so this becomes x cube. And as you can see that the elimination is not happening, but this expression will be multiplied by a minus sign. So the sign of each and every term gets changed. So x raised to the power of 4 minus x raised to the power of 4 gets cancelled out. And x cube is being subtracted from 0x cube, which means that here we have minus x cube. And 0x square will be carried forward as it is. And then we need to ask ourselves by what term we multiply x such that we get minus x cube. We need to multiply x with minus x square. Okay, such that we get minus x cube underneath exactly. And then this minus x square will be multiplied by 1. So this will give us minus x square. And bazahiran elimination nahi ho rahi. As we can see that elimination is not happening, but you will multiply this expression with a minus sign so that the sign of each and every term gets changed. Okay, so this becomes plus and this also becomes plus. So, this gets cancelled out. The cubic term gets cancelled out, and 0x square plus x square, which will give you positive x square. And then 0x will be carried forward as it is. And then you need to ask yourself by what term you multiply x such that you get x square. Obviously, you multiply it with x so that you get x square underneath exactly. Okay. And then this x is multiplied with 1, so this gives us positive x. And then this expression is multiplied by a minus sign, so the sign of each and every term gets changed. So x square term gets cancelled out, and 0x में से x subtract करना है. We need to subtract x from 0x. Okay, so here we go. Here we have minus x. And then this minus 1 is carried forward as it is. And then we need to ask ourselves by what term we multiply x such that we get minus x. So we multiply it with minus 1. So here we go. The term in x comes underneath exactly. And then this minus 1 is multiplied by 1. So this will give us minus 1. And then this expression will be multiplied by a minus sign. So sign of each and every term gets changed. And the remainder is 0. We have obtained the remainder 0 over here. So this means that, when polynomial is divided by divisor, okay, when x raised to the power of 4 minus 1 is divided by x plus 1, so this gives us a quotient, a cubic quotient, which is x cube minus x square plus x minus 1. But our requirement is not yet completed. Now what we need to do, we need to express this cubic polynomial as a product of linear and a quadratic polynomial. Our answer will be completed when the cubic polynomial, the quotient over here, which we have obtained over here, the quotient So our requirement will be completed once this cubic quotient is expressed as a product of linear and quadratic. This makes sense or not? So for that purpose, assume that we have a polynomial which is x cube minus x square plus x minus 1, and you don't know any factor. And if this polynomial was equated with 0, so you don't know any solution, any root. Okay, so these questions you are studying since P2 as well, where a polynomial needs to be factorized and you don't know the factor, you don't know any of the factor. And if the polynomial, is equated with 0 and you need to solve the equation, you don't know any root. So what you do the trial and error method. Okay, historically, the trial and error method, the traditional trial and error method is used. However, what you can do is that more effective technique is to use your calculator equation function. Just go in your calculator equation function mode and choose polynomial with a degree of 3 and just, put this cubic expression over there. Assume that this cubic expression is equated with 0 and you need to solve the equation. So just put this cubic expression in your calculator equation function mode and you will see that x is equals to 1 is a root. You would be able to identify that x is equals to 1 is a root. Okay, so you need to show the steps that you are substituting x is equals to 1 into this cubic equation so that, the whole outcome of this equation is equal to 0. So 1 cube minus 1 squared plus 1 minus 1, this whole thing is equal to 0. Therefore, x is equals to 1 is a root and x minus 1 is a factor. These all concepts we are studying since P2. Okay, so P3 students must be well versed with this concept as well. Okay, we don't know the first root, we don't know the first factor, so we use the calculator equation function to find the first root, and by that way we find the first factor. Or we just use the trial and error method, but more effective way is to just do it in this way. So x minus 1 is a factor. Okay, and now you need to just divide this cubic polynomial by x minus 1 and remainder will be 0 so that you get the quotient. Just do this. I'll take a short break for Azan. Azan is happening. So just do this. Okay, so as I was saying that, x is equals to 1 is a root we have identified using the calculator equation function mode, and therefore x minus 1 is a factor. And now we are going to, divide this cubic polynomial by x minus 1. And as we know that x minus 1 is a factor, because already established x is equals to 1 is a root, so obviously the remainder is going to be 0. So you need to ask yourself by what term you multiply x such that you get x cube. Obviously you multiply it with x square. Okay, so x multiplied by x square is x cube, and then this x square is multiplied by minus 1, so this is minus x square. And the elimination is not happening, so this expression will be multiplied by a minus sign, and the sign of each and every term will get changed. So this becomes minus, this becomes plus, and our purpose was to eliminate the cubic term, but meanwhile in the same procedure x square term also got eliminated. हमारा मकसद एक्स क्यूब की टर्म को एलिमिनेट करना था, लेकिन इत्तेफाक ऐसा हुआ कि एक्स स्क्वायर की टर्म भी एलिमिनेट हो गई, कोई मसला नहीं. सो हेयर यू विल राइट 0x square. Okay, and then we will carry forward x as it is and then minus 1 as well, because when the comparison actually starts, and the coefficient of this first term is 0, so you can just simply ignore this term as if it is not existing even. Okay, I've discussed this thing in the previous P3 lecture as well, I guess lecture number 1.2 or maybe 1.3, सही से याद नहीं है. लेक्चर नंबर 1.2 या फिर 1.3 में मैंने ये बात डिस्कस की थी. आई हैव डिस्कस्ड दिस थिंग इन ईदर लेक्चर नंबर 1.2 or 1.3. Okay, so make sure to watch all of the recordings in sequence, okay, which have been shared with you. Make sure to watch all of the recordings in sequence, okay, and you don't need to skip anything in between. Anyways, so here the starting term is actually not over here. It is eliminated because x square term is not existing anymore and the coefficient of x square is 0, so you can just simply ignore this term. Okay, so you need to ask yourself by what term you multiply x such that you get x. Obviously, you multiply it 1, so you get x underneath as it is, and then this 1 is multiplied by minus 1, so this will give us minus 1. And this expression will be multiplied by a minus sign, so the sign of both terms get changed and the remainder is 0. So therefore, we can say that, since the identity we are studying, that polynomial is identical to quotient multiplied by divisor plus remainder. So in place of this cubic polynomial, I can write quadratic expression multiplied by linear expression, meaning quotient multiplied by divisor. So quotient is x square plus 1 and the divisor is x minus 1. But we need our answer in a specific form. First, we have the linear factor, then we have the quadratic factor. So we are just going to make a comparison with ax plus b multiplied by cx square plus dx plus e. Okay, so therefore x minus 1 multiplied by x square plus 1. So therefore a is equals to 1, b is equals to minus 1, c is equals to 1, d is equal to 0, and e is equals to 1. Okay, so this was the alternative approach. All right. Both approaches will give you equal marks. Okay. So that is basically the thing. So this was question number 10 of exercise 1C. Okay. And after this, we are going to start the past paper handout of this chapter number 1. So I'm going to make a separate recording for that for my YouTube channel, and I will share that video as part 2 of lecture number 1.4. Okay. This recording is part 1 of lecture number 1.4, and here I conclude this part. So I'll just offer my prayers, Maghrib, and then I will make the recording for part 2. Okay, and I will share that as a public video lecture. So stop recording. This was part 1 of lecture number 1.4.